good afternoon friends, and in this video we are going to understand about the rational fractions. Rational fractions are, so let me remove this part. We are going to understand what are rational fractions. So if you divide a polynomial fx by another polynomial gx, you get an expression, and this is called as rational fraction. So rational fraction is actually the quotient of two polynomials when one is divided by another one, right? So now we can have different situation, like you know that there is a, what is it? First let me write here, fx is a polynomial. So when this term is called as proper rational fractions or improper rational fractions, in arithmetic you understand that the proper fraction is a fraction of kind 5 by 7, 7 by 11, like that, where denominator is more than numerator. So denominator is greater than numerator, and these kind of fractions are called as proper fractions. And improper fractions are improper fractions are the fractions where the numerator is more than denominator, like 8 over 3, 10 over 7, like that. And you also know that these improper fractions can be expressed as a mixed fractions, where one part is integer and the other part is fraction. For example, this 8 over 3 can be written as 2 plus 2 by 3. Now you see this 2 is your integer value and the 2 by 3 is proper fraction. So improper fraction can be written as integer value plus the proper fraction. Same way 10 by 7 can also be written as 1 plus 3 by 7. And we generally write in this form 2, 2 by 3, and here 1, 3 by 7. Same way, if degree of the polynomial, if degree of fx is less than degree of polynomial gx, that this is called this is degree of polynomial fx is less than degree of polynomial gx, then this is called proper rational fraction. Proper rational fraction. And otherwise, when degree of numerator, the polynomial in the numerator or fx, is greater than degree of polynomial gx, then this is called as improper fraction. And this improper fraction can be broken down as a polynomial plus a rational fraction, and that should be proper. The proper rational fraction. So now I'll explain the whole idea again by taking some suitable examples. So now here I'm taking one example and trying to break this down as rational fractions, and these rational fractions, in the next video we'll learn how to integrate these rational fractions. So in this video our priority is more on how to express the rational fractions into sum or difference of the improper, like the proper fractions. So here we have one which is 3x minus 1 over x square minus 1. So the method goes like this: you write it as 3x minus 1 over x minus 1 x plus 1. So this is x minus 1 x plus 1. This is factorization of this denominator only is expressed. So now this goes into the form of a linear over quadratic, and this you can write it as a over x minus 1, this one, plus b over x plus 1. Now you take the LCM. So this is x minus 1, x plus 1, and this becomes a times x plus 1, a times this value plus b times x minus 1, and this is equal to 3x minus 1 over x minus 1 and x plus 1. So these two fractions have the same denominator. Now their numerators can be compared. So we have 3x minus 1 is a times x plus 1 plus b times x minus 1. Now we have to solve this equation and find the value of a and b. So how can you do that? First you do one by one. Suppose you say x minus 1. So if you let x as was kind of hit and trial method, if you let x as 1, then this part vanishes. So right, let x is 1. So 3 ones are 3 minus 1, that is 2. A 1 plus 1 is 2, and this part becomes 0. So 2a is 2, therefore a is 1. So you got a is 1. Now next time assume x as minus 1, because x plus 1 it is. So minus 1 plus 1 will become 0. So we are trying to select the values of x so that these particular terms vanish one by one. So here I write x equals minus 1. So 3 minus 1 minus 3 minus 1 is minus 4, and this becomes 0, and this becomes minus 2b. So b is 2. So a is 1 and b is 2. So our final one, this is a is 1, this is b, and this one has been broken down into two fractions. Like this fraction is the sum of these two fractions. Now instead of integrating, if you integrate this one, it will be much more easier. So in this video we are only focusing on how you can break down given rational fraction into sum or difference of two or more proper rational fractions. Like this, these fractions are proper rational fraction. So now I take one more example. Now this equation, this form is x cube minus 6x cube minus 5x square minus 7 over 3x square minus 2x minus 1. 3x square minus 2x minus 1. So here you see this is a polynomial of degree 3 and this is a polynomial of degree 2. Means degree of polynomial of the numerator of the polynomial in the numerator is greater than degree of polynomial in the denominator. Therefore this is improper rational fraction, and now we can divide this. So you can assume that you are dividing numerator by denominator. So you can write here 6x square minus 6x cube minus 5x square minus 7 over here, don't need this one, I divided by 3x square minus 2x minus 1. So this goes 2x times. So this is 6x cube minus 4x square minus 2x. Now I subtract. So plus. So here you are getting minus 5x square. Minus 5x square plus 4x square is just minus x square. This is minus 2x, plus 2x minus 7. So now we have 3x square and we need to get this term, that is minus x square. So now I write just minus 1 over 3x. So this becomes minus, don't need this x also. So minus x square, and then this is plus 2 by 3 x and plus 1 by 3. So if I change the sign here, plus minus minus, these two cancel. Now we have 2 minus 2 by 3. So 2 minus 2 by 3 is 3 to the 6 minus 2, 4 by 3. So this is 4 by 3x, and these two are negative, like the minus 7 minus 1 by 3. that is minus 22 by 3. So we can write this expression as this times like the 2x minus 1 by 3 plus remainder, which is 4 by 3x minus 22 by 3 divided by this 3x square minus 2x minus 1. Those who understand that how do we find, like suppose I just go back to arithmetic, and suppose we have 22 by 7, then we divide 22 by 7, this is 3. 3 is the quotient, 21 times, this is 1 remainder, and then we write this and 1 by 7 plus, or sometimes we write 3 1 by 7, both are same thing. So it means that here we'll have this one is quotient, this part, plus this is remainder. So if you say this is remainder Rx, this is your remainder Rx, this is your dividend, I can call it as dx, and this is your quotient, that you can take it as qx, and this whole will become like this. So now here you see this one part has been broken down as 2x minus 1 by 3. From the top I can take 1 by 3 common, so this one as it is, plus 1 by 3. This one can be written as, sorry, no integration, we can write as x minus 22 upon this term, which is 3x square minus 2x minus 1. Now you can write 2x minus 1 by 3 plus 1 by 3 x minus 22. Now is it possible for you to factorize? Let me check. This is 3x square minus 2x minus 1. So 3x square minus 2x minus 1, middle term splitting. 3x square minus 3x plus x minus 1, 3x common, x minus 1 plus 1 common, x minus 1, x minus 1 and 3x plus 1. Yes, this can be broken down as 3x plus 1, and that is x minus 1. So let me clear this part, and then I will resolve this part into the rational fraction. So here we have x minus 22 over 3x plus 1 times x minus 1 as a over 3x plus 1, means a upon this first linear polynomial or the linear expression plus b upon x minus 1. Then again take LCM, this is a times x minus 1 plus b times 3x plus 1, and this is 3x plus 1 times x minus 1. This is x minus 22 over 3x plus 1 x minus 1. Now both these expressions, left hand side, right side, both have the same denominator, so we'll compare their numerator. So x minus 22 is a times x minus 1 plus b times 3x plus 1. So now you take x equal to 1, so a part vanishes and this part becomes 3 1 is 3 plus 1 4b, this is 0 and this is minus 21. So you are getting b as minus 21 over 4. Now next time when you want to eliminate this b, so 3x plus 1 there, so you assume x as minus 1 by 3. So x as minus 1 by 3, this part 0. Now minus 1 by 3, so this part will become minus 1 by 3 minus 22 is a times minus 1 by 3 minus 1, that is 66 minus 67 by 3, and this is minus 4a over 3. 3 cancel, negative negative cancel, so a is coming as 67 over 4. So this value you are getting as 67 by 4, and the b value got as minus 21 by 4. I make this one as minus and this one as 21 by 4. So now this fraction is broken down into this form. Finally we have this, means this whole thing multiplied by 1 by 3 plus this part is also there. So now these are the ways by which you can express a given fraction into the sum or difference of two or more proper rational fractions. Now I'll take one more example and then I'll explain it again. Okay, now I want you to look at them in the proper form. So the first form, you saw that you have 1 over x minus 1 or x minus a x minus b. Then this also you can write as a over x minus a plus b over x minus b. Or you can also, because this one I'm taking it as a polynomial of degree 0, this constant polynomial, and this is a polynomial of degree 2. So in this condition you can take the case is very much same, like the degree of the polynomial in the numerator is less than the degree of polynomial in the denominator, and the form is that these two are factorized form. So if I have one more form which goes like, suppose x a minus whole square x minus b, then this is expressed as a over, for this x minus a whole square you have to write two times, first for x minus a and then for b x minus a whole square, and then for c take another fraction, that is x minus b. Again you have to take the LCM of them and then you have to find the coefficients of a and b by comparing the coefficients methods or by any other methods which you are comfortable with. Now next time, if I have x minus a whole cube, then what I have to do, you have to write it as a over x minus a plus b over x minus a whole square plus c over x minus a whole cube. So these are the ways by which you can solve. So I want to solve at least one form, so I'll go for this second one, because if I solve second one, the third one can also be covered. So let me remove this part. I write the LCM directly, then I get the LCM will be x minus a whole square times x minus b. There you'll get a times x minus a x minus b plus b times x minus b plus c times x minus a whole square, and this is 1 over x minus a whole square x minus b. So now I just compare their numerators because denominators are already same. So it is 1 is a x minus a x minus b plus b is x minus b plus c is x minus a whole square. Now how to find the value of these coefficients, because if you put x equal to a, suppose if I put x equal to a, so this part vanishes, this part vanishes. So a, because a x minus a is 0, x minus a is 0, here there is no x minus a, so you will get 1 is capital B a minus b, therefore b is 1 over a minus b. One value you have already found. Now next time if you want to put the value of x as b, then you find that this becomes 0 and this becomes 0. Then I say if x equal to b, then this part 0, this wherever you have x minus b, that part will vanish. So we get x equal to c b minus a whole square. Then you find c is 1 over b minus a whole square. So we have found b, we have found c, but we have no other variable to substitute, so we cannot find c directly. So what we do, that we can put the value of x as 0, suppose, or any other number. That was, I'll prefer 0 because this will make the job easier. So in the third case I write x as 0. So I'll get 1 equals 0 minus a, 0 minus b, is minus a and minus b, this become aba, and this part will become minus b capital B, minus b capital B, and this part becomes a square c plus a square c. Now you have to solve this equation to find the value of a, because the value of the capital B is already known to you and the value of the capital C is also known to you. So if you put these two values in this, you can find the value of a directly. This looks little tedious in this case because this is all expressed in the algebraical equations. But if it had been a value with the numerical coefficients a, b, c have just numerical values, then this equation will be very simple to solve. But I was just discussing the very technique required to solve these kind of equations. So I just did my part, and then in the next video we will take some questions, and then our focus will be on to integrate them, and at the same times we'll also be breaking down those given expressions into the proper rational fractions first, and then we'll integrate. And this method of integration is called that integration of partial fractions. Thank you very much. Just subscribe to our channel and keep learning with us.